One of our major goals in this section is to build up a sort of a library of valid argument forms so that when we see one of these forms, we don't need to do a new truth table every single time. We can recognize that this is a form that we've already studied. And this first example shows one of the valid argument forms we're going to be interested in. This argument form is called Indirect Reasoning. It also has a Latin name. I'll tell you about that in the next video. So our example argument that uses this form is going to be, all runners are athletes. Lydia is not an athlete. Therefore, Lydia is not a runner. In order to show that this argument is valid, we'll analyze it using a truth table. In order to do that, first we need to identify the premises and the conclusion. So here we have that helper word therefore, helping us find the conclusion. And that our conclusion must be Lydia is not a runner. We'll fill that in first. The other two sentences are going to be our premises. All runners are athletes, and Lydia is not an athlete. Now, the first one of our premises is one of those universal statements that we're already familiar with. It tells us something about the category of runners and the category of athletes. In order to symbolize it, as we've seen before, we have a fancy word, instantiate it. We need to apply it to an individual. Now there's an individual that we're talking about in this argument, namely Lydia. So we'll apply this argument to Lydia. What does all runners are athletes say about Lydia? Well, it says that if she's in the category of runners, she also has to be in the category of athletes. Our first premise, when we instantiate it for Lydia, becomes, if Lydia is a runner, if she's in the category of runners, then she's in the larger category of athletes. If Lydia is a runner, then she is an athlete. In general, when we're working on an exercise like this, it's not necessary to write that down, but you can write it down if you find it useful for this next step. Because now we need to find the simple statements. With our first premise instantiated like that, it's easy to see what the simple statements are about Lydia. Because our simple statements are Lydia is a runner, we'll call that P, and Lydia is an athlete, we'll call that Q. Our first premise, all runners are athletes, means if Lydia is a runner, then she's an athlete. So that's if P, then Q. Our second premise, Lydia is not an athlete, that's not Q. And our conclusion, Lydia is not a runner, that's not P. So that's the form of our argument. If P, then Q, not Q, therefore not P. Let's analyze that now using a truth table. We'll have a column for the first premise, if P, then Q, a column for the second premise, not Q, and a column for the conclusion, not P. In this case, we didn't need any extra columns in order to get the symbolization for those, because again, each of those combinations only includes one combining symbol, either an if-then or a negation. There's only one step to each of those. So now when we go through to analyze this argument, we have first our conditional premise, if P, then Q. Remember, if then is false when the if part is true, but the then part is false. That's the only time. The rest of the time it's true. So if P then Q, we see the if part is true, the then part is also true, the if then is true. The if part is true, the then part is false. That's the only time that if then is false. And then in the next row we see the if part is false. Doesn't matter what the then part is, if then is true. The if part is false. That means the if then has to be true. Okay, so that was the hardest one. Now for not Q, we just want to negate Q. So whatever the truth value of Q is, not Q will be the opposite. Opposite of true is false. Opposite of false is true. Opposite of true is false. Opposite of false is true. Okay, and then last column. Not P is just going to be the opposite of whatever P is. So the opposite of true is false. Opposite of true is false. Opposite of false is true. Opposite of false is true. Okay, there's our truth table. What do we do with it? We want to examine the rows where the premises are both true. So here are our premises. So in this row, our second premise is false. In this row, our first premise is false. In this row, our second premise is false. The only row we have where all of our premises are true is this row. So in the fourth row, where P is false and Q is also false, that's the only place where both premises are true. What is it that we're looking for in this row? We're looking for the conclusion to also be true, and that is what we see. Since we see any time that the premises are all true, the conclusion is also true, we conclude that this argument is valid. And we could have predicted that because it said this argument is valid at the top of the page. So it's a good thing that we actually did find that this was a valid argument.